we call arithmetic series. Arithmetic series. In our previous class, we did discuss the concept of series, and we said that series can be defined as the sum total or the sum of the terms of the sequence. This time, the definition is not deviating, only that we are going to be smuggling in the concept of arithmetic sequence in it. So what is arithmetic series? Arithmetic series is simply the what? Is simply the sum of the terms of an arithmetic sequence. That is all. For instance, if we said that the terms of an arithmetic sequence is given as T1, T2, T3, T4, T5, all the way down. Then the sum of this series, of this sequence is T1 plus, T2 plus, T3 plus, T4 plus, T5, also all the way down. Yes, I would have loved to prove this to us, but I don't think that is suitable for this class. I'll just give us the formula. But nonetheless, there's a particular knowledge I would love to bring to your notice. And that is a particular story I heard about the advent of this particular concept a long time ago. About a young boy who was in class and was causing trouble in class. The teacher wanted to get him occupied, called him and asked him to write 1 to 100 and had it up. So for a young boy that was in the basic class, that would be a lot of work and a lot of punishment for him. But to the amazement of the teacher, this student finished in no time. And the man was so surprised. He told the teacher the answer is 5,050. How did you get that? That was too fast. Then he explained to the teacher. He said, what I did is this. What I did is simply say 1 plus 2 plus 3 plus 4 plus plus 100. So the teacher was watching. Then he said again, I said 100 plus 99 plus 98 plus 97 plus plus 1. So I had it up. So I said this plus this is 101. 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 All the way down to 100 plus 1 is also what? 101. Don't forget there are 100 terms here and there are 100 terms here. Meaning that there will definitely be 100 terms of 101. That means 100 times 101. And don't forget that this sequence is written twice, ascending and descending order, divided by 2. 2 here 1, 2 here 50. And that gives us 50, 50, which is 550. That was how this concept came. Do you understand? So that is the same way I'm putting to you how we got the sum of the nth term of an arithmetic series. But I'm not going to go there. I'm just going to give us the formula. Then we'll take 1 or 2 basic examples that can solve or unify a point as it were. So stay with me. Okay, so the sum to the nth term of an arithmetic progression is defined as Sn equals n all over 2, 2a plus n minus 1 bracket d. When I call this the sum to the nth term of an arithmetic progression, when the last term is not known, I need to say when the last term is not known. So where we have Sn is called sum to the nth term. And when we have n is the number of terms in the progression. Terms in the progression or sequence. Then what we have A is that a popular first term. Then what we have D is our known common difference as it were. So that is what this is for. Do you understand? But when we go on and expand this further, something like say Sn equals n all over 2, and write 2a as a plus n minus 1 bracket d, close the bracket. What do you observe? From here to here, it looks something familiar. If you follow the class, it's called as this is the definition for the nth term of an AP. Tn equals a plus n minus 1 bracket d. You remember? So in other words, Sn is equals to n over 2 a plus Tn. But this Tn can also be written as n, which is called last term. So Tn can also be seen as last term as it were. So Sn is equals to n over 2 a plus n. Just as so, it's either we're using this particular formula or this particular formula based on the parameters that we have at hand. Do you understand? So this or this will suffice to solve for the sum of an arithmetic sequence. Like I said, I'll try to take on 2 examples on each of these 2 so we can know when and where to use them. We have one once again. Now let's take an example that can buttress our point, the point I stated lately. Look at this. But before I go on, I need to spell out to you that you need to know that your n, which is number of terms in the progression, can only be what? Can only be a whole number. Yes, it can be decimal, it can be fractional. You can't have 4.5 terms in the progression. It's either 4, 5, 6. Do you understand? So please keep this to heart. It's very, very essential. Albeit, I think I need to further make you see the beauty of this particular example. The beauty. Imagine that you are given 2, 4, 6, 8, and 10. This is just 5 steps, 5 elementary terms. So we have 2. I ask to add it up. So that means it becomes 2 plus 4 plus 6 plus 8 plus 10. If you do it manually, 2 plus 4 is 6, 6 plus 6 is 12, 12 plus 8 is 20, 20 plus 10 is 30. But what if I want to go that way? I already know that I have my first term is 2, my common difference is 2, 4 minus 2, 6 minus 4. So my common difference is 2, and my number of terms in this progression is 5. So how do I have it? I'll just simply use my formula of Sn equals n over 2, a plus n. Then I will say, what is my n? S5, 5 over 2, a, 2, n, last term, 10, becomes 5 over 2 times 12. 2 here 1, 2 here 6. 5 times 6 is simply 30. So instead of me doing manually, it's a formula that can help with my computation without stress as it were. So that's one of the beauty of this formula. But let's take an example that can help us to know exactly when to use the first formula. Once again, recall that these are the 2 formulas I stated that can be used to solve the sum to the nth of an AP. Do you understand? So let's take an example so I can let you know when to use this and when to use this. So look at this example. Solve the following. Number 1. Imagine I have solve for the sum of the first 20th term of this progression. Let's say you have 5, 10, 15, 20, and it goes on. Then number 2, you have to solve for the sum of the terms of this sequence, of this what? Sequence. So I have 5, say you have 5, 7, 9, all the way down to 43. So how do I solve for this? So the method by which I'm going to solve this one question is just different from how I'm going to solve this number 2 question. Do you understand? Even if both of them are referred to the same term, which is arithmetic series. Look at the one. I'm asked to solve for the sum of the first 20th term. Means that I'm going to be using my first formula easily. Not that I cannot use the second formula, but it means I have to first of all go and look for the last term of that progression of all the big 20th term, and I now have to use this. But to do that easy is just to use this first one by simply saying that my first term is 5, common difference is this minus this 5, this minus this 5, this minus this 5. So my common difference is simply what? 5. And my n has been spelled out 20. So I put 20 here. So what am I looking for? I'm I'm solving for x20. That is what I'm asked to solve for. So I'm now saying that x20 is equals to 20 over 2 because n is 20 over 2, then 2 times 5, 20 minus 1 bracket d. What is my d? My d is simply 5. Close the bracket. So what do I have? 20 over 2 is what? 10. 2 times 6 is 10 plus 19 times 5. And that will give us 10 open bracket, 10 plus this is 45, 4, 1, 9 times 5 is 45, we put 4 here, 5 times 5 is 95. Then that becomes what? 10 times this plus this, 105, 1,050, 1,050, without stressing yourself. Meaning, like I said, you can also use this method, but you need to try to find your end stamp, which is also your last stamp of this progression, then you now put it in and you have the same answer. Do you get it? So let's start number 2. Also the same thing, the best way of number 2 is to use this method because you can see your first term and you can see your last term without stress. But you have been told that it's an AP. So I will now say that my first term is what? N is equals to what? Equals to 5. And my last term, my first term is 5A, and my last term is what? My last term is simply 43. Do you understand? But the only issue now is that we don't know N. So I need to go and solve for my N. So what do I solve for my N? I will recall that what? I will recall that Tn equals to A plus N minus 1 bracket D. That is the end stamp of my AP. So what's my Tn? I just told you that your Tn is the same as your last term, which is this. I will say 43. My first term is 5 plus, I am solving for N minus 1. My common difference is simply 7 minus 5 is 2. 9 minus 7 is 2. I put 2 here. So I connect that times. I will say 43 minus 5. Expand the brackets. 2 times N. 2N. 2 times 1 minus 2. And this will give us 38 equals 2N minus 2. And eventually, what will I have? I will collect like terms. It becomes 2N equals 38 plus 2. 2N equals to 40. N equals to 40 over 2, and that is 20. Meaning there are 20 terms in this progression. Having known that, I'll then go to say that my S20 is equals to 20 over 2, just like I have here. Sorry, like I have here, 20 over 2. My first time is 5, my last time is 43. So what does that give me? 2 here is 10. This plus this is simply 48. When it is added up, it becomes 480. And that is easy. So the moment you understand how to drag out parameters, when and where to use them, it becomes quite easy to evaluate these things. So I believe this is clear enough as touching arithmetic series. But I need to also spell out to you that there is nothing called sum to the end term of an arithmetic progression. You can't sum it to the end term. It's going to blow. It's not going to have a converging number as it were. So but keep that to heart and do quite a number of examples yourself. Example make you to master concept in mathematics. So thank you so much for being part of this class. Do well to subscribe and turn on your notification bell to be updated the moment we post a video.